Hello students, today the topic we are going to study is the context-free languages and context-free grammars. Till now we have gone through so many examples of regular languages and we have drawn so many deterministic finite automatas and did a lot of practice till midterms on the regular languages. So what is a regular language? A language that can be defined by some regular expression or some finite automata, and finite automata can be either DFA or NFA, though DFAs are a little bit difficult to directly draw or create, so we can use the help of NFA. NFAs are easy to make a language for any NFA, to make a NFA for any language is easier than DFA, and then we convert that NFA, we can convert that NFA to equivalent DFA to be very deterministic. So, but there are some languages, there are some tasks that cannot be done using context, that cannot be done using finite automata. For example, consider a language, let me drop. Consider a language where the language is AN, BN. It clearly says that if we have two A's, then there should be two B's. If we can have three A's, we should have three B's. If we have four A's, and then we should have a four B's, and N can be a very, very long number. So for these types of languages and so many other languages that we will see during the code that cannot be defined from any finite automata or DFA or NFA, we need some different things, different rules or different advanced techniques to handle this. So here it comes the context-free languages. So context-free languages can handle regular languages and it can handle also some non-regular languages. For example, if this language cannot be handled using DFA, so we can handle this language using context-free languages. So you may ask, like, what is so special about this language? Why we need to take care of these types of languages where A and B, and so why we need to do this? Consider a programming language where you use so many arithmetic expressions, or during arithmetic expression we use so many times the brackets. So here, if we open a bracket, it must be closed, right? If we have two brackets open, then we should have two brackets closed. So let's say A is equal to this and B is equal to this. So it leads to so many other applications. So for arithmetic parsing, arithmetic syntax checking, context-free grammar is the gold standard. And we will see for a simple calculator, the expressions can be x plus y multiplied by z. Either this is a correct syntax, either this can be generated using any grammar. So we will see, and we will be doing so many examples on arithmetic types of grammars or languages. Okay, so context-free language allow us to describe non-linear languages, and the non-linear languages have so many examples. So, but how do we define context-free grammar? Using some grammars, we define some language. So, in grammar, we have some rules. For example, I try to give you one very simple example. Let's say, prove me that A is equal to 3. Prove me that. So, it can be proved very easily if you just put A is equal to 3 directly. So now if I say A is a language that can generate only the A 3 multiples, like we can generate 3, we can generate 6, we can generate 9, we can generate 12. So all the multiples of 3 can be generated from a single variable A if we define some rules. For example, let's say A is equal to 3. A can be equal to 3 plus A. If I have these two rules in my hand, then I can generate all the multiples of 3 with a single variable A. let's say I say that let's prove that a is equal to 6. Either the 6 is the multiple of 3 or not. Though we have a smart calculators, we can do it like this, but when we talk about some grammar rules, we have to see either this can be generated from the above two rules or not. So to prove that a is equal to 6, so instead of a, like we in linear algebra, we can easily put the we can put anything instead of a. Variables can be replaced with some constants, or variables can be replaced with some other variables. So if I say prove that a is equal to 6, so what you will start from, if you put a is equal to 3, then 3 is not equal to 6. So you will not put a is equal to 3. This rule will not be applied here. Instead, you will put a is equal to 3 plus a instead of a. So it is clear we are not going to put a is equal to 3. Instead, we need to increase the value from 3. So we need to keep variable inside the rule so that we can replace variable with some other constant. So instead of taking a is equal to 3, we will take a is equal to 3 plus a is equal to 3 plus a. Alright, so but still it is not, now we have option either. Again, we can replace this a with, we can replace this a with, again, a is equal to 3 plus a, or I can put a is equal to 3. When I put a is equal to 3, we cannot further derive anything. So this is equal to 3 plus, now instead of this a, I write a is equal to 3 and this is equal to 6. What if I have to prove that a is equal to 9? If I have to prove a is equal to 9, then instead of a, I will take rule number, let's say this is if I label it, this is rule number 1 and this is rule number 2. Okay, so I will use rule number 2. So rule number 2 says instead of a you can write 3 plus a. Then again I will use another, instead of a is equal to 3, I will again use rule number 2. Then it will be 3 plus a. And now using rule number 1, 3 plus 3 plus 3 is equal to 9. So when we get the we say that the constants, we cannot further derive. The word usually used in this CFG is derive. We cannot further derive because all constants have been placed, and we can execute this statement successfully. When we execute this, we get 3 plus 3 plus 3 is equal to 9. So this is an example where we define some rules, and using that rules we make any language happen. Like this, the language is the multiple of 3. So you can go for a very long number, you can check either like a is equal to a very big number. Of course this is going to be a very long step, but still we can check either this can be generated from this language or not, and we cannot make any DFA for this sort of languages. So in coming lecture, in the coming video, we will define what is a context-free grammar. How do we define a context-free grammar? So stay tuned for next video.